All right, welcome to our last video for Unit 7. This is Unit 7, Note 6. And check your notes sheet because I believe I typed it as Unit 7, Notes 5. On your white notes sheet, you can change that to Unit 7, Note 6. Last one for Unit 7. Now we are putting things together. We did combinations and permutations earlier in the unit. Then just recently we talked about probability. Now we're doing probability with combinations and permutations. So just a few reminders, things that we should remember. The combinations and permutations formulas are listed there. N factorial over n minus r factorial times r factorial for combinations. And for combinations, we also need to remember that order is not important. Order does not matter. We don't care what order things are grouped in. Permutations, on the other hand, now our formula n factorial over n minus r factorial. Here, order is important. This is when we're ranking things like first, second, third, or in order of how we like something, or anytime it says arrangement or line them up, put them in a line. That's a different order, okay? So that would be permutations. Now we're going to use combinations and permutations to find some probabilities today. Let's take a look at number 1. In number 1, it says a combination bike lock requires a 3-digit code made up of the digits 0 through 9. No number can be used more than once. And first, the first thing that we should do, we need to determine, is this permutations or combinations? In this case, it's a combination lock. Now, we know that we can't switch the combination on a combination lock. We can't change the order, so this would be a permutations. Okay. Now, the next thing that we need to know, before we start finding any probabilities, we should know how many total combinations there are. So part A, that's the very first thing that you find, and that's the note that I have here. You might want to write that down on your page. Always find the total number of ways first. That's going to be the bottom of your probability fraction. So in part A, it says how many different combinations are possible. Well, there's 10 different digits in 0 through 9. And we're doing permutations, and we're choosing 3 of those digits. So it's 10p3. That means I have 10 factorial over 10 minus 3 factorial, which is 720 codes. And like I said, that's going to be the bottom of our probability fractions. Okay, now here's where the probability part comes into play. Let's look at B. B says, what's the probability that all the digits of the code are odd? So we need to know how many odd digits are there and how many ways can we arrange those odd digits. The odd digits are 1, 3, 5, 7, 9. So there's 5 of them. So if I'm going to arrange a 3-digit code, I'm going to have 5 options for the first digit, 4 options for the second digit because it says no number can be used more than once, and 3 options for the third digit. Multiplying that out, 5 times 4 times 3 ends up being 60. So there's 60 ways to have an odd digit code. There's 720 total codes. So 60 divided by 720, you can use your calculators. By the way, you might want to have your calculator out for this lesson because there's lots of big numbers that have to be divided. So 60 divided by 720 gives us 0.083. Okay, let's look at the next one. I'm going to get rid of this stuff. There's my delete, there it is. In the next one, part C, what's the probability that the first digit is 3? So now if we think of our 3-digit code, that means this digit has to be a 3. No number can be used more than once. So after I use the 3, then there's only, I'm sorry, let me back that up. This digit has to be a 3. There's only one 3 in the list. Then I have 9 options left because I've used the 3. So I have 9 options left for the next number. Then once I use a number there, I have 8 options left for the last number. So 1 times 9 times 8 is going to give me 72. And again, I have 720 total possibilities. 720 possible codes, so 72 out of 720. That's the same thing as 0.1. So let's just talk through how I got these numbers here again. There's only 1 3 in the list, so there's only one way that I can list 3 in the first spot. Once I use the 3, then I have 9 digits left. After I pick a number for the second spot, then I have 8 digits left. Okay. And the last one, let's look at part D. In part D, what's the probability that the code is 1, 2, 3? So 3 digits. I want my numbers to be 1, 2, and 3. There's only 1 1 in the list. There's only 1 2 in the list. And there's only 1 3 in the list. So there's only one way that I can get the code 1 2 3. If I find the probability of that one code out of the 720 total possibilities, that means my probability is 0.001. So very small chance that that's the code. Let's take a look at number 2. In number 2, it says we're looking at a word processing program. There's a 7-digit registration code. The digits are listed there, 1, 2, 4, 5, 6, 7, and 9. So not all the digits are listed, but some of them we can use. Each number has to be used, and no number can be used more than once. So again, this is going to be permutations, perms, because we're talking about a code, which means it has to go in a certain order. And again, the first thing that we should do is to figure out how many different registration codes are possible. I'm using all 7 codes, so this is, or all 7 digits, so this is going to be 7 factorial. And I get the 7 from 1, 2, 3, 4, 5, 6, 7 digits. Okay, so 7 factorial ends up being 5,040 codes. Okay, now that's going to be the denominator of all of my probability fractions. So part B, first probability we're looking at, says what's the probability that the first 3 digits of the code are even? So here's what I need to know. I need to know what the even digits are. The even digits in this case are 2, 4, 6, and that's it. There's just 3 of them. And the odd digits, because I'm going to need to know those as well because I'm using all the digits, are 1, 5, 7, and 9. So there's 3 even digits, 4 odd digits. So let's set up our code. There's seven digits in our code. 1, 2, 3, 4, 5, 6, 7. I want the first 3 to be even. If the first 3 are even, that means that the next 4 are all odd. And remember that we can't repeat digits. So I have 3 possibilities for the first even digit. Once I use one of them, then I only have 2 possibilities for the second even digit. Once I use that one, then I only have 1 left for the third even digit. But I also have to place the odd. I'm going to have 4 possibilities for the first odd digit, because there's 4 odd digits to choose from. Then once I use that one, then I have 3, then I have 2, then I have 1. When I multiply those all out, 3 times 2 times 1 times 4 times 3 times 2 times 1, I get 144. So my probability is 144 out of my total, which was 5,040. This again is where you're going to want your calculators, 0.029. Okay. Let's try the next one. What is the probability that the first digit is 1? So again, if I set up my 7 digits, I have 1, 2, 3, 4, 5, 6, 7. I want the first digit to be 1. There's only one way that that can happen because there's only 1 1 in the list. Now, once I place that 1, I have 6 options left for the next digit. Then I use that number, 5 options left for the digit after that, then 4 left, and so on, all the way down. When I multiply that out, that means there are 720 different ways that I can have the code where 1 is at the beginning. There's 720 ways. So for my probability, 720 ways where 1 is at the beginning, 5,040 ways total, That's where we get a probability of 0.143. Okay. I want you to do part D on your own in number 2, and we're going to jump down to number 3. In number 3, Mr. Domingos is setting up some volunteer tutors. There's 12 students, or he's choosing 12 students out of a group of 7 seniors, 5 juniors, and 4 sophomores. Now, this is one where there's 12 kids, they're going in a group. We don't care what order they're in, so it's combinations. Okay, combinations here. Again, the first thing that we have to do is to figure out, put your marker down. There we go. How many total combinations the 12 students could be chosen in. So I have 16 students total because I have 7 plus 5 plus 4, which is 16. And I'm choosing 12 of them. That's 16C12. Think back to that combinations formula. There it is. When I plug all that in, I end up with 1,820 possibilities. Okay, 1,820 different ways that those groups, or that group of 12 students could be chosen. So now let's look at part B. It says, what's the probability that he chooses 4 seniors, 4 juniors, and 4 sophomores? 3 things happening here. Choosing the seniors, choosing the juniors, choosing the sophomores. So for the seniors, we're going to need the combinations formula for all 3 of these. For the seniors, I have 7 to choose from, and I'm choosing 4. For the juniors, I have 5 to choose from, and I'm choosing 4. And for the sophomores, I have 4 to choose from, and I'm choosing 4. Now you're going to want to go through and calculate all 3 of those. When you calculate all 3 of those, you end up with 35 here, you have 5 there, and you have 1 there. Multiplying those together, 35 times 5 times 1 ends up being 175. Okay, so there's 175 ways that you could get 4 seniors, 4 juniors, 4 sophomores. To find the probability, I would take 175 and divide it by my total number of ways, 175 out of 1,820. You end up getting 0.096 for your probability. Okay, let's find the next one. Part C. What's the probability that all 7 seniors are chosen? Okay, now keep in mind we're choosing 12 people, but we want to know how all 7 seniors can be chosen. So we've got the seniors are choosing all 7 of them, so that's 7C7. Now we have to think about the rest of the group. There's 7 seniors, there's 9 students in the rest of the group. Okay, so out of those 9 students, I'm going to have 5 of them that I have to choose. So I have 9C5 because I already picked 7 seniors. So I need 5 others because that 7 and 5 is going to give me the group of 12. There's only one way that you can choose all 7 seniors. 7C7 is 1. When I do 9C5, I end up with 126. 1 times 126 is 126. Doing the probability, 126 divided by my total number of ways, which again was 1,820. I get 0.069. That's my probability. Okay. All right, we're going to end up stopping there for now, and we're going to look at number 4 in class tomorrow. So thanks for watching the video for tonight, and we will see you tomorrow.